Hello students. In the last class, we were started with the unit 2, that is the engineering in IoT. So in last class, we have discussed about the sensors, actuators, different types, and how the sensors and actuators are different, and how it will be interacting each other, sensors and the actuators, and the working principle, how these actuators and the sensors will be working, and different types. All these things we have discussed in the last class, and in today's class, we are going to discuss about the more about the smart objects. So already in the last class, I was given the introduction about the smart object. So smart object means, so it is just kind of a project, automatic project we can call. So which will be having the sensors, which will be having the actuators, which will be having the microcontroller chip. So and it will be deciding its own, and it should be able to so work its own automatically. So those kind of objects we can call it as the smart objects. And this is one such kind of topic. So that is the micro electromechanical systems. So we call it as the MEMS. Okay, so one of the most interesting advances in the sensors and the actuator technology is in how they are packaged and deployed. Okay, so that is so related to the sensors and the actuators. So how it is deployed, that is the very most important point. And coming to here, so here this MSME sometimes simplify the referred to as the micro machines. Okay, so this MSME, it can be called as the so micro machines. Okay, so micro machines means so it will be in the so very small in size, and it will be doing the work efficiently. So those we call it as the micro machines. Okay, I'll give the examples of the micro machines. So how it will be very useful for our daily life. So and all those things we can so discuss in this. And then so coming to this, okay, so micro machines, so it will be having the sensors and the actuators, so which will be in the size of the micro level. Okay, micro sensors, micro actuators we are going to use in this. So MSMEs. Okay, so that is MEMS. Okay, that is the micro electromechanical machines, or simply we can call it as the micro machines. Okay, so in the 19th century, so this micro machines, it has got the boom, and then it has gained the several advantages compared to the macro machines or the big machines. So in the 19th century, so most of the companies, so they have tried for the so this micro machines. Okay, what are the major micro machines which we are using are micro pumps. Okay, and where we are using this micro pump space, so in inkjet printers. Okay, in the inkjet printers, though that ink will be so injected using those micro pumps. Okay, micro pump is a such kind of micro machine. So are the accelerometers which will be there in the smartphone, that is also one small micro machine. Accelerometer is basically micro pumps, and the accelerometers are the micro actuators. Okay, so it will be embedded in the smartphone. It is a very tiny one, so it can be classified as the micro machines. So are the airbag accelerometers. So in the vehicles, whatever the airbag it will be present. So that mechanism, that entire setup is also the so it is a micro machine one. Okay, or it will be categorized into the micro machines. And the gyroscopes in the smartphone. So gyroscope already we have discussed in the last class. So for the angle movements, okay, we use the gyroscope in the smartphone. That is also a best example for the micro machines. Okay, so there are several micro machines are there. Even the stitching one, so that is the sewing machines, micro machines are there. So for some particular applications, so where we can't use the so big sewing machines, so there we can use the micro machines. Okay, so there all we are using this MEMS. Okay, and This is one such kind of machine. So here in the diagram wise it is looking very big. So but the size of this is, so it is in the nanometer. So here it is given, so it is in millimeter and nanometer, that is the dimension. Okay, so overall dimension it is there in the millimeters. Okay, so millimeter means, so it is lesser than a centimeter. Okay, so how much they have written is, so this is just a 15 mm. Okay, so 15 mm, so that much small machine it is. So what it is means, it is the torsional ratcheting actuators. Okay, TRA we call MEMS. So this is a one such kind of sieving machine. Basically, it is one small micro sieving machine. So it is shown here. So such a kind of micro machines also uses the sensors and the actuators. Okay, so details are written here. So about that. And then, so we should discuss about the smart objects. Okay, what are we can call it as the smart object. So smart object are quite simply the building of blocks of IoT. Okay, so whatever the building blocks of IoTs are there, so there we should use the smart objects. Definitely it should be smart sensor, smart actuator, smart gateway. So all the components should be in smart. So so we can call it as the building blocks of IoT. They are what performs everyday objects into the network. So of the intelligent objects that are able to learn from and then interact with their environment in the meaningful way. Okay, means smart object, it should be having its own ability to learn. Okay, so in the daily ongoing aspects, so it should learn and it should take its own decision and smartly it should act. Okay, that is the meaning of that. So that is the meaning of smart actually. So in this smart farming sensor, so described precisely, already we have discussed about this smart farming. If a sensor is a standalone device, so that simply measures the humidity of the soil, and it is interesting and useful. So means if it is a standalone sensor, so it can check the humidity of the soil. But if it is a but it is not the revolutionary. Means wherever we fix, so there it will be sensing the humidity and it will be giving the information. So even if we carry the humidity so instrument, so directly also we can measure that. So there is nothing much in that. So then what is the next level is, so that is if that same sensor is connected as a part of an intelligent network, means if that sensor is the intelligent one, so then that is able to coordinate intelligently with the actuators to trigger the irrigation system as needed based on those sensor reading. And so that is a more meaning. Okay, means, so if that is the intelligent one, that humidity sensor, so it should actuate the sensor, and if the water is required, if the humidity level is less, we can pour the water, otherwise so we can turn off the valve. So those activities will be so done. So means, so if it is a smart one, all these work should be happened, then we can call it as the more powerful instrument. Okay, that is the meaning of that. So only sensing the humidity, so in that no much stuff is there. So that is extending to that. So even further, imagine that coordinated sensors actuator set is intelligently interconnected with the other sensor actuator sets to further coordinate fertilization, pest control, and so on. Means, so whatever the sensors and actuators, so wherever we keep, so in the fields, so there may be so more than 5, 10 sensors, more than 5, 10 actuators. If those, okay, aggregate the data and if they decide its own, so how much water is to be poured, and regarding the fertilization, whether any fertilization is required in any particular part of the field, or if any pest, okay, so affected, so if pest control is to be done, so for some plant, so those kind of things, so all decisions can be done. So this overall we can call it as the smart object. Only sensing, so are only actuating, so it won't make the smart object. So smart farming means, so we should be able to sense the data and we should be able to control the all the parameters. So all the parameters means that may be water, fertilization, pest control, so are any other aspects of related to the. And then, so here smart object definitions. Okay, so that is, so a smart object is a device that has at a minimum the following four defining characteristics. Okay, means if the smart object is having these four characteristics, whatever the four characteristics it is mentioned in the PPT, then we can call that object as the smart object. And what are those four characteristics is processing unit. Okay, so smart object, it should be having the processing unit. So processing unit means it is a microcontroller chip. Whatever the sensor, it senses the data, it will be coming into the processor, and processor process the data and it decides what is to be done, means action. Okay, it will be decided by the processing unit. So that we call as the processing unit. So smart object means, so 100% it should be having the processing unit. And then second thing is it should be having the sensors and actuators. So definitely, so smart object means, so it should be sensing and it should be actuating the several processors. So definitely it should be having the sensors and the actuators. And the third thing is, so that is the communication devices. Okay, communication unit is responsible for connecting smart object with the other smart object and the outside world. Means if that data, whatever it is processing, so that is to be stored or that is to be accessed, or that data is to be sent to the other smart objects or other smart work. So otherwise, if that data is to be sent to the cloud, so all those things are required means, so definitely the communication devices are required, internet is required. So that is the third most important thing in this smart object. And then the fourth one is the power source. So smart object have a component that needed to be powered. Means sensors require the power, actuator requires the power, microcontroller chip requires the power, and then so this communication devices requires the power. So all the different components, it requires the power. So definitely the power is the main thing in the smart object. So smart object means it should be having the processing unit, sensor, communication device and power source. And this power source, it can be by the, so our regular supply, or we can use some solar panels or wind turbines for the power supply, or the battery backup. So it can be anything. So power is required. And then, so in order to increase the efficiency, sleep mode should be there, and always we should try for the ultra low power consumption hardware. So it can be sensors, actuators, microcontroller chip or communication devices. So whichever the devices are consuming the less power, so that we should use, so that overall power consumptions or power requirement can be reduced. Okay, so we can use the solar or the batteries, so any other sources or our regular power supply can be used for this purpose. Okay, and this is one overall view of the smart object. And in this smart object, so here CPU is there. So this CPU is, so that is the processing unit. Then here one actuator is there. So here this is the sensor, this is the actuator. Then the communication antenna is there. This is for the communication unit. So memory is there to store. Then the power source is there. So all the aspects which we have discussed, it is there in the small smart object. Means it is one small object or the small block diagram of whole. So which is having all those four characteristics. So that is the processor is there, and then sensor and actuators are there, communication device is there, and the power source is there. Okay, so this is one small so block diagram of the smart object. Okay, and then trends in smart object. Okay, so what are the trends which are existing in the present days related to this smart object? Okay, so what are the main trends means size should be decreasing. So if you want to design any smart object for a particular application, so always you should target for the so small size or the micro vision size. Okay, always those things will be so appreciated, means compacting the overall size. Okay, so as much as possible, so how much it is possible to reduce the overall size, that much we should reduce. Okay, and then the next is the power consumption should be decreasing, means whatever the objects or whatever the elements we are going to use in the smart object, those should be consuming the very less power, so the power overall power requirement will be reduced, and even we can use the small batteries or so if it is a small power consuming means those projects can be implemented in the remote areas, so if it is a low power consumption one. Okay, so that is also one of the major trend in the smart object. So one is first is so always we should target for the reducing size, and second one is we should target for low power consumption, and then third one is that is the processing power is increasing. Okay, means whatever the processing of data or whatever the microcontroller chip we are using, so that should processes the data very fast. Okay, means always we should use the so processing unit, so which can be able to process the so that required things very fast. Okay, that is the meaning of this. That is the processing power is increasing. Always we should try to increase this processing power. So next is that is the communication capability are improving. So always we should so try for so very good communication capabilities, means many wireless technologies are there or internet technologies are there, communication protocols are there. So it should be so such that so we should get we should be able to communicate very fast without any delay. Okay, so that capability it is, and the communication is being able being increasingly standardized, means there is a strong push in the industry to develop open standards for IoT communication protocols, and presently whatever the protocols are existing, it is not dedicated or so related to the IoT, it is not standardized. So standardizing, so it is much required here. So already many IoT architectures are mentioned for the different industries, and so by the Cisco they have established the many architectures, and the IoT WF architectures or M2M architectures are existing, but not in the all the industries. Only few industries are standardized. So it is to be standardized. So that is the so IoT communication protocol related to this. This is also one trend. And then so next is SANet, that is the sensor network. Okay, sensor actuator network, or in general we call it as the sensor network. So in short we will be calling this as the SANet. Okay, so means what is the SANet means? So that sensor if we are keeping, okay, and then so communication is required between this sensor and then the so processing unit, are the processing unit and the actuator, communication is required to gather the data or to send the data. Okay, so there we require the sensor networks. Okay, that is we are discussing here. Sensor or actuator network, as the name suggests, is a network of sensors that sense and measure their environment, or actuators that act on their environment. The sensor or actuators in SONET are capable to communicating or cooperating in productive manner. Means communication between the sensors, actuators, or the sensor processing unit, actuators. Okay, so there definitely we require the network, so that we are discussing. Then the effective and well coordinated communication and cooperation is the prominent challenge, primarily because the sensors and actuators in SONET are diverse, heterogeneous, and resource constrained. Okay, means so we buy the sensors from the different companies of the different principal actuators with the different principal, different mechanism. Okay, so if the coordination is to be happened between those objects, means that is a diverse, heterogeneous, whatever they it is mentioned in the PPT base. So there should be a proper communication and cooperation. So definitely this SONET is the very important thing. So while such networks can theoretically be connected in a wired or wireless fashion, so means to the processor, if we connect through the wire also or through the wireless, okay, also the fact that SONET are typically found in their real world means so that they need an external level so of deployment flexibility. So this is a very important point. So it can be wired or wireless things. So we should give more preference to this. Okay, and here following are the advantages and disadvantages. So that a wireless based solution offers means in this SONET. So if it is a wireless one, so then these are the so some of advantages and disadvantages. So which are mentioned in the PPT. So that is greater deployment flexibility will be there, means so if it is a wireless one, so deployment flexibility will be there. So we can keep it anywhere. Okay, so at some different places within the range. So that it will not be existing in the wired one. Then simpler scaling to large number of nodes it is possible. So if it is a wireless, large number of nodes can be placed and it can be communicated with the nodes, means the end devices. Then the lower implementation cost. So if it is a wireless, so then definitely the implementation cost will be less. So because at the appropriate place we can fix those or we can place those. And the easing long term maintenance means overall maintenance can be reduced if it is a wireless one. Then effortless introduction of new sensors and actuators nodes means so if we want to introduce or if we want to connect one more sensor or one more actuator, if it is a wireless one, so directly, so without any ambiency, so we can means we can connect. Okay, that is the effortless introduction. Then next is the better equipped to handle dynamic rapid topology changes, means whatever the topology we are going to use, so that will be so very better in the wireless one. And then disadvantages potentially less secure. So if it is a wireless means any means so other persons can steal the data. So security level, so it is a less. Then typically lower transmission speed. So this overall transmission speed will be less of the data, and the greater level of impact are influenced by the environment. Means it will be having so impact or the influence on the environment because of the wireless networks or the radiation. So these are the major disadvantages. And then next is the wireless sensor networks. Okay, so already that's on it we were discussing. So if it is a wireless sensor network, so then so how it will be that we are discussing. Advantages, disadvantages already we have discussed, and what is the meaning of wireless sensor network, that also we have discussed. So I have skipped the introduction, and the main thing in this is following are some of the most significant limitations of the smart object in the wireless sensor networks. So that is the limited processing power. So if it is a wireless one, processing power will be limited. That is a major limitation. Then limited memory. So if it is a wireless one, so limited memory is the limitation. lossy communication, wireless means, so some data, so loss may happen, so that is also major limitation. So then limited transmission speed, so that speed, whatever the speed of data transmission, that will be reduced, that is also limitation. Then the limited power. So limited power means, so if it is a wireless, so it will not be having the, so more power to, so interact with the other devices. So that is also one of the major limitation. So these limitations greatly influence how WSNs, that is the wireless sensor networks, are designed, deployed and utilized. Means, so while designing, deploying, the utilizing, so we should take consideration of this and we should try to improve this as with this becomes increasingly feasible. 15 years back, this sensor was too high, this processing unit it was by the implementation, the putting of the means by the using of the more close together sensors, processing units, they decrease this implementation means it has become many sensors are very expensive and elected. The ability to so increased accuracy. Okay, this is also one of the very important point. Okay, so number of sensors. Okay, so then, so it is possible to introduce the hierarchies of smart objects, so such that we can increase the, so accuracy of the system. Means, so always in the sensor, what is the major disadvantage is accuracy of those sensors. Okay, how to improvise that accuracy of the sensors means by deploying the different sensors at the different points. Okay, means, so this, okay, in this, so in the hexagon shape, so six sensors are placed. Okay, and all these six sensors are, so measuring the temperature. Okay, and it is telling, so different values. Okay, and then, so if we take the average value, that will be more accurate one. Okay, so actual is, or the average is 11.7. So this sensor is telling 11.7, this is telling 12.2, 13, 11.3, 11.8, 12.1 and 11.5, except the one sensor, remaining all the sensors are telling the different values. So if we take the averaging of those values, it is possible to reduce the error or it is possible to increase the accuracy. Okay, that is what in the previous slide and here, so it is shown here. Okay, and wirelessly connected generally have following communication pattern. Means if it is a smart object, so within these two, so it should be having one communication pattern. That is the event driven one or the periodic one. Okay, so within this, so any one communication pattern it will be having. So event driven means transmission of sensory information is triggered only when smart object detects a particular event or so predetermined threshold. Okay, event driven means whenever some kind of particular phenomena happens, okay, then only it will be sensing. Okay, otherwise it will not be sensing, it will be quiet. Okay, or if a timer is there, so monthly once, okay, that event is to be captured or that event is to be sensed, or daily once or hourly once. Whenever that time comes, only that time it will be activating it. Okay, that we call it as the periodic one. Okay, that is the second one. And the event driven means, so whenever we send the so some of the signals or some of the input to sense the data, or whenever some particular phenomena happens, so that kind of type we call it as the event driven. Okay, so broadly, so it can be classified into event driven type or the periodic type. So this smart object, it will be having any one of these two patterns. Okay, and then the communication protocols of wireless sensor network. So this is the self-learning content. So and it is already, so these materials are shared. So you can go through this protocols. Okay, and then communication criteria. So coming to communication criteria, so already it is mentioned here. So this criteria. So following sections closely at these criteria means smart object communication criteria. Okay, so criteria are range. Okay, so range means, so that is a signal propagation and distance related one means, so what is the range of this communication? Okay, whether the sensors at the gateway we are keeping at 10-meter distance, 100-meter distance, or in centimeters, how much long we are keeping this, and that gateway, okay, how much long it should communicate with the sensors. Okay, that range is the first criteria. Always depending on the range, we will be so deciding the technology. So that is the wireless technology. So whether to go for the Bluetooth, whether we go for the Zigbee, or whether to go for the Wi-Fi, or whether to go for the this LoRa. Okay, so that is the first criteria, range. Always we should give preference to this range in the communication criteria. Second is frequency bands. Okay, so frequency bandwidth, at which frequency level, sub gigahertz frequency level, we are transmitting or receiving the frequency. So in the LoRa, so we were selecting, so we were discussed about the Indian so communication frequency level, that is a 865 to 867 so megahertz. So we were selected, so bit more than the 865 megahertz. So always which frequency band we are going to select for the communication, that is also a very important criteria. And then the power consumption, whether the any separate backup is required, whether it is a battery powered one, or any other sources or the renewable sources are required. Okay, so that is the means this power consumption is the next criteria, important criteria, and next is the topology. Okay, topology. So for the communication, so which topology we are going to use? Whether the star topology, mesh topology, or the other kind of hybrid topologies. That is also one of the very important things. So that we should select, or we should give the more preference to that. And then next is the constraint devices. Okay, so this we are going to discuss in the next about the what is the meaning of constraint devices, means limitations of certain smart objects from the connectivity perspective. Okay, so that is the meaning of constraint one, and the constraint node network also we are going to discuss. Okay, so that is the so challenges that are often encountered with the network connecting smart objects. Means, so that constraints, okay, we can simply the constraint meaning you are knowing. So it is like the constraints, okay, so which are existing related to smart objects. Okay, that is, and then the range it is specified here already. So that is the first criteria. So but the diagram is shown here. Okay, so that range, okay, if it is a Wi-Fi, how much, so different Bluetooth, means different wireless technologies, Bluetooth, Zigbee, Wi-Fi, the Wi-Fi, different technologies, Wi-Fi, BGN, AC, AS, are the IEEE 802.15.4 GE or IEEE 802.15.4 are so wireless technology, so 1901.2 PLC. So these are the medium range one. Long range means 2G, 3G, 4G, 5G are the long range one. Short range means Bluetooth. Depending on our application, we should select this different communication. So that can be classified into short range, medium range, and the so long range. So here that is the first criteria. So here short range means we can go for the Bluetooth or IEEE 802.15.7. Okay, our medium means already it is mentioned there already. So spoken about that. And when the so long range means so it can be any cellular networks or some Wi-Fi. So that is the IEEE 802.11 Wi-Fi or the LPWA, that is the low power wide area, or the lower band. So frequency bands are mentioned. Okay. So then the for IoT access, these are the most well-known ISM. Okay, that is the so 2.4 gigahertz band is used for the IEEE 802.11 BGN Wi-Fi, or if it is a IEEE 802.15.1 means it is a Bluetooth one, and IEEE 802.15.4 means it is a wide private area network. Okay, so these uses these different ISM bands. Okay, so normally, so who is going to specify these frequency bands means so particular telecommunication agency of that nation. Okay, different nations. So even our India is having the so one regulatory committee. Okay, so that has decided the so our frequency band. So like that, all the different nations will be having the different agencies. They will be deciding the communication or the frequency band. Then power consumption, related to this power consumption already we have discussed. So it depends on the application, whether the separate battery power is required or so direct power supply, or depending on the application. Application means so how frequently so that is sensing or activating or processing the data. So if it is a water meter means only monthly once, the utility meter. So monthly once it is possible to detect that, means we can sense that and we can generate the bill. So if those kind of applications means it can come up to 10 to 15 years. Okay, small battery it can come up to that much of time. Or gas meters means it can come up to 5 to 7 years. Okay, so that is related to the battery consumption, and topology already I discussed. So we can use this star topology, mesh topology, or peer-to-peer topology. Okay, topology means in middle processing unit will be there. So all the nodes it will be connected to that middle point. So in the star fashion. So that we call it as the star topology. Mesh topology means so in random it will be connected to each other and it will be checking for the aggregation of data. So that kind of technology we call it as the mesh topology. In IoT most of the times we go for the star topology, and peer-to-peer topology means so in this fashion. Okay, here so one so main processing unit is there and it is connected to each and everything. Okay, so this point is connected to all the remaining 3 points and this is connected to all the remaining 3 points, and then at the end it will be sent to so that main node. That is the peer-to-peer technology. Okay, and constraint devices. Okay, depending on this constraint, so we can classify the so devices into 3 classes: class 0, class 1, and class 2. Okay, so and definitions are given here depending on the different constraints, means depending on the so this RAM capacity and all. Okay, so class 0 means nodes is severely constrained with less than 10 KB of memory, means it will be having 10 KB of memory and less than means flash processing memory will be less than 100 KB, and even the storage capability also less than 100 KB. So those we classify into class 0. And class 1 means it will be having more, okay, more than the previous one. So that is approximately 10 KB for RAM and approximately 100 KB flash, okay, and okay, IP, okay, so refer thing both are. So that classified into class 1, and class 2 means so more than that, okay, that is the memory of 50 KB and flash of 250 KB. So that classified into the class 2. Okay, and then the constraint node network. Okay, so this is also self-learning unit. So depending on the data rate and throughput and the latency and determinism. Okay, so this constraint node network. Okay, so those are the constraints: data rate and the throughput, latency and determinism. So this should be discussed for all the different wireless technologies. Okay, so related to this. So that is also one main constraint or constraint node network. Okay, this is about the unit 2, and one more small concept is remaining, that is the IoT access technology. Okay, so here particularly the following topics to be addressed of the IoT access technology means for the different wireless technologies. So it should be so discussed. Okay, means so that is the standardization and alliance, and then physical layer of that wireless or the wire technology, then the MAC layer of that, which topology is being used, then the related to security and competitiveness of the technologies. Okay, these are to be discussed. Okay, and here one. Okay, so I have shown here means if it is a IEEE 802.14 means, so it is a wireless protocol for connecting the smart object, and related to this all those previously whatever I have shown here, so those are to be discussed. So these are the different wireless technologies, okay, LoRaWAN, NB node. Okay, for this, so this IOC technology means how much ray, means how much standardization is there and alliance is there, physical layer of that, MAC layer of that, topology, security, competitiveness of technology. Everything is to be discussed for all these different wireless technologies. It is mentioned in the textbook, and already I have circulated this material. Okay, it is to be so studied. Okay, this is also self-learning unit. And in tomorrow's class, I am going to discuss about